sine law and cosine law. So the sine, cosine, and tangent ratios can be used for right triangles only. If we have an oblique triangle, this is a triangle that does not have a right angle, we can use either the sine law or the cosine law. So first, the sine law. There are two forms of the sine law, here and here. Now, the way each of them works is that we have a side. Now, sides are given lowercase letters, so lowercase a, b, and c. Each of these sides is divided by the sine of the same letter, in this case capital A. Those are the opposite angles. So A is divided by the sine of the opposite angle, B divided by sine of the opposite angle, and same thing for C. Now we can flip that whole thing upside down. We can have the angles on top. So in this case, sine A is divided by its opposite side A, and so on and so on. As long as it lines up, each of the ratios that you're using, it doesn't matter what is on top. Now, sine law can be used in situations where you know the measurement of one angle and the measurement of its opposite side. So for this problem, I want to find the measurement of side B. So what I see here is side B is opposite to 58 degrees. So those two are going to be paired up for the sine law. Now the other side that I have, 33 yards, I actually don't know what the opposite angle is just yet. But what I can do, if I know two angles in a triangle, I can figure out the remaining angle by subtracting those two from 180 degrees, because the sum of the angles is 180. So that would be a 75-degree angle, and I'll draw it in there. So this is important. Don't just look at a triangle and then assume right away, okay, I'm going to use those two angles and then this side. You have to make sure that the side and angle are opposite to each other. Alright, so now I can use the sine law, and one trick that we're going to use, if you put your unknown value on top, it makes life a lot easier. So B, side B, would be divided by its opposite angle, so sine 58 degrees equals. Now because I put the side on top, I have to put the side on top again, so 33 would be divided by its opposite angle, so sine 75 degrees. Now at this point here, I want to isolate B. I want that all by itself. Now the reason why I like to put that on top is we are now dividing B by sine 58. Now if we're dividing by sine 58, if I want to get rid of that, I can multiply both sides by sine 58. So 33 divided by sine 75 and then multiply by sine 58. That will give me B isolated. So now I can just multiply that out. I don't need you to evaluate this, write down all the decimals, and then multiply by this one. Just do all of that on your calculator. It's not a problem. Now, to one decimal place is how we normally round our side lengths. So if I get 28.97, that would actually round to 29.0. In this case, the units is yards. Alright, so there's my answer. Now, one thing that I want you to pay attention to, we didn't talk about this previously when we reviewed trigonometry quickly, but this answer, side B, is not exactly 29.0 yards, and when we say that something is equal, that means exactly equal to. So what we can do is, because we rounded our answer, I'm going to put a little dot over that. This means that B is approximately equal to 29.0 yards. So if you have to round your answer, I will now be looking for that. We'll go over in class how to find an angle using the sine law, but I want to quickly look at the cosine law now. Now, sine law was used when you know the measurement of an angle and its opposite side. If I take a look at this triangle right here, I don't know what this opposite side is, and I don't know what these opposite angles are, so we can't use sine law in this situation. This will be a good place to use cosine law. Now, cosine law is used when we have a side angle side situation, which means you have two side lengths and then sandwiching an angle in between, or side, 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 which means you have all three sides of the triangle. Now, this is only if this equation, if you're finding side C. So it changes slightly if you're using B or if you want to find side A, for example. Now, you don't have to rearrange the equation. What happens is, so if I want to find side B, I'm just going to swap B with C here. So in this case, I will have b squared equals, and then a squared plus c squared, because I'm swapping b and c, and then minus 2 times a times c, so again c has to take the place of b, and then times cosine of, and then again instead of angle C, it will be angle B in this case. Now you don't have to write out the formula like this each time, you just have to start using it. So if I want to find out side B, which would be opposite of angle B, so B squared would be equal to, side A is 25, so 25 squared, plus side C, opposite of angle C, is 27 squared. But it doesn't really matter what order those go in, you'll get the same result. And then 2 times the first side times the second side, and then times cosine of angle B. Now you can type in all that on your calculator and write down all the decimal places that it gives you, but that might lead to some errors. So at this point, what we know is this gives us what b squared is. So I'll have to square root this side to isolate just b, and then I'll have to square root this entire side. So you don't have to show me an additional step for cosine law, just show me that you are square rooting all of that, and then you'll get your answer. So b is equal to, I get 27.99, so that would round up to 28.0, the units are centimeters, and just like before, that would be approximately because I did round my answer. So that's a quick review of sine law and cosine law in terms of finding sides. We will work on finding angles in class.